Hello, everyone. Welcome to the final review video. This is going to go over the topics we've covered since the second midterm. If you want to see the topics before the second midterm, you can go ahead and look at the midterm 1 and midterm 2 review videos. And so a note about that is actually the final is cumulative. So it would pay off to go ahead and review what you've covered for the previous midterms, because that material will probably be on the finals. Okay, so let's go ahead and start off by sort of listing the sections and kind of covering what we've done so far. So the section right after the second midterm was section 2.7, and that one was on combining functions. So we combined functions algebraically with addition, subtraction, multiplication, and division. We also combined them using composition. That was the little O thing. Okay, then section 2.8, that was on one-to-one functions. And their inverses. And that mainly talked about, so started off with the horizontal line test. Which is kind of like the vertical line test, except, the line's horizontal now, and it checks to see if a function, or rather the graph of a function, is of a function that is one-to-one. And we also talked about how to show, showing f is or is not one-to-one. And we did that mostly algebraically, showing these things algebraically. And then we also talked about finding, in the case that f is one-to-one, finding the inverse of f. We did it both algebraically and graphically. So we did it both ways. All right, and then we switched over to chapter 3. And 3.1 was on quadratic functions and models. And so in that section, we talked about standard form, which I did not do a very good job at all of explaining how to find the standard form of a parabola. And I will re-explain this as soon as I finish this list, because I did not do a very good job at all. And the other thing we also talked about was the vertex formula. And we also used these things, used these ideas to find maxes and mins on parabolas. And then lastly, section 3.2 talked about polynomial functions. And their graphs. To that end, we talked about the end behavior. We talked about the roots and zeros. And in the last video, I also talked about the multiplicity of roots. And I also talked about using test points. And these 4 tools kind of make up the main toolbox you use to graph polynomial functions. So they're all important. All right. So that was sort of a list of the key ideas that we've covered since the second midterm. So again, since I did not do a very good job of explaining how to use completing the square to find the standard form of a parabola, let's go over that now. So a better explanation for completing the square. And hence, finding the standard form of a parabola. One of the problems I had with the last video is after the fact, I realized I dropped the negative. So my answer is wrong too in that video. So we're going to go ahead and redo that example correctly. But before we go into that, let's talk a little bit about why we're doing the things that we're doing to put it in standard form. So completing the square uses the perfect squares formulas. So this is the key thing to remember, is that when we're completing the square, what we're really doing is we're putting part of this parabola in a perfect square format, and we want to use the perfect squares formulas to then change it. So if you remember, the perfect squares formulas were, a squared plus 2ab plus b squared. That was all equal to a plus b all squared. And similarly, a squared minus 2ab plus b squared is going to be a minus b all squared. And so it's these right here that give us what I wrote down last time, which was this strange x squared plus bx plus b over 2 squared equals x plus b over 2. What I've actually done is I've used this first one, and I've let a equal to x, and I've let the big B, so here a is equal to x, big B is equal to b over 2, okay? And so doing that gives you this back out. And then what I failed to mention last time was that if you've got x squared minus bx plus negative b over 2, that's going to use the other one, this one right here, and you'll get x minus b over 2 squared. And this was the formula that I really wanted to use in the last video. And so hopefully that makes a little more sense. So let's do the redo of that example. So we had f of x equals 3x squared minus 12x plus 6. And so first, we wanted to focus in on the first two terms. So just grouping them with parentheses just so we can kind of visually distinguish them. And so now we want to take this leading coefficient in front of x, and we want to pull it out. And don't forget, we also have to pull it out at the second term. And so we get 3 all times x squared, and then 12 divided by 3 is 4. So we get minus 4x there, plus 6. All right, everything is just like last time so far. But now here, take a quick side note, when we apply this perfect squares formula, remember, we want to apply it to the thing inside the parentheses. And so here, b is negative 4, which means that when we do our negative b over 2 squared, we're actually going to want to use negative 4 over 2 squared. And so now, we do that, we get x squared minus 4x plus negative 4 over 2 squared plus 6. And then, of course, we have to subtract the same thing. And that's going to end up being 3 times negative 4 over 2 squared. Some of you were a little confused about why we have to have this 3 in front here. So a quick explanation is if we take this 3 here and we multiply it back in, we get 3x squared minus 12x plus 3 times negative 4 over 2 squared plus 6 minus 3 times negative 4 over 2 squared. And so the reason we've got the 3 is because we want this term to cancel with this term if we were to expand it back out. And once they cancel, you get back the original equation. So everything is equal. But that is why we have to have that 3 out in front on this line right here. Okay. So going back to the main problem. Oops. There we go. Now we can apply our perfect squares formula to this thing in here. And what we'll get out is x minus 4 over 2 all squared plus 6 minus 3 negative 4 over 2 squared. All right, and now it's just simplifying. So we've got 3x and the 4 over 2 is just 2. So this is minus 2 squared plus 6 minus 3 times negative 2 squared. And then we get 3x minus 2 squared plus 6 minus 3. Negative 2 times negative 2 is positive 4. So we'll get that. And then a couple more steps. 3 times 4 is 12. And then lastly, if you subtract 6, if you subtract 12 from 6, negative 6. And so this is the correct answer. Hooray. And so from here, some people had difficulty taking this and finding the vertex. You have to remember, so recall that the standard form is ax minus h squared plus k. And you have to be very careful because this is a minus and this is a plus. And so when we look at the thing I've boxed in green here, our standard form for our parabola, the vertex is going to be positive 2, negative 6. Okay, as you put a 2 in for h, you get x minus 2. That's what we want. You put a negative 6 in for k here, you get minus 6. That's what we want. So the vertex here is 2, negative 6. All right. Let's see maybe a second example because I think that would be good. So let's do maybe something a little bit simpler, a little bit quicker. Let's do x squared plus 6x plus 13. This one's interesting because you can't factor it. Its roots are complex, but we can still put it into standard form. So let's look at the first two terms. Let's focus on them. And this x squared secretly has a 1 here, but since there's no leading coefficient besides just 1 there, we don't have to factor anything out. We can just leave it as is and proceed to the next step where we add and subtract. So plus 6x, and then we're going to add, in this case, our b is 6, so we get 6 over 2 squared plus 13, and that's just, there we go, 13. And since, again, there's nothing out here in front, just a 1, we can subtract off 6 over 2 squared, just like that. If you like, you can secretly think that there's a 1 here. All right. Now we apply our perfect squares formula. And when we do that, we get x plus 6 over 2 squared, because now we're using the positive version of the perfect squares formula, plus 13 minus 6 over 2 squared. All right, 6 over 2 is just 3, so let's write that. 13 minus 3 all squared, and then we get x plus 3 squared plus 13. 3 squared is 9. And then the last step, if we do that subtraction, we get, plus 4. All right, and then if we use our standard form understanding, we can pull the vertex out. So the vertex for this one is at. Now you have to be careful. The standard form is x minus h. So here, the x coordinate is actually negative 3, because if you put a negative 3 in for h, you'll get x minus negative 3, x plus 3. So that's good. That's what we want. And then for this one, this is just 4. So that vertex is at negative 3, 4. All right. Hopefully that was clearer than the original lecture on leading the square. I recommend, especially if the first one is confusing and you had difficulty with the homework, going back and looking at those 2 homework problems, and now that you kind of have a, hopefully you have a more solid understanding, maybe going back and looking at those again, it should make a lot more sense. And you should be getting the right answer if you follow this kind of method. All right. Well, you should also have access to a practice final by now. And I recommend go ahead and look at that, work through some problems. And of course, if you have any questions on any of it, feel free to shoot me an email or stop by office hours.